Assalamualaikum, my name is Nur Irdina binti Khaira Izwan. So today, me and my groups will be presenting about the techniques of differentiation. First of all, let me introduce my group members first. First, we have one Nur Amizah binti Wan Ahmad, Siti Nur Aina Najihah binti Muhammad Misami, and Nur Zaima Zakirah binti Muhammad Nur. What is differentiation? Differentiation is the process of finding the rate of change or slope of a function. For example, velocity is the rate of change of displacement with respect to time. Instantaneous rate is the rate at which something changes at one exact moment. Graphically, differentiation refers to finding the slope of a curve at one specific point and measuring the gradient of graph.
Next, we have techniques of differentiation. We have constant rule, power rule, chain rule, sum and differences rule, product rule, and quotient rule. For the first question, I will explain how to differentiate this function. The function given is y equals to sin 3x over sec of x plus 3. First, we need to simplify the equation by changing sec into cos, because sec theta equals to 1 over cos theta. We got y equals to sin 3x times cos of x plus 3. Then, we get u equals to sin 3x and v equal to cos x plus 3. U prime equals to 3 cos 3x and v prime equals to negative sine of x plus 3. After that, we use the product rule. dy over dx equals to u times v prime plus v times u prime. dy over dx equals to sine 3x times negative sine of x plus 3 plus cos of x plus 3 times 3 cos 3x. The final answer is dy over dx equals to negative sine 3x sine of x plus 3 plus 3 cos 3x cos of x plus 3.
So now I'm going to explain to you about question 2k. For this question, I need to differentiate the function y equals to ln bracket 3x plus 2 and tangent bracket x cubed. This function is a product of two functions, so I'm going to use the product rule. First, we're going to let the u equals to ln bracket 3x plus 2 and v equals to tangent bracket x cubed. Using the product rule, dy over dx equals to uv prime plus vu prime. We're going to find the u prime and v prime. For the u prime, u just now that were equals to ln bracket 3x plus 2, we're going to differentiate and change the ln into 1 over x and differentiate the value in the bracket. So u prime will equals to 3 over 3x plus 2. Next, I'm going to find the v prime. For tangent x, I will apply the chain rule, and the derivative of tangent x is secant square x. Therefore, v prime will equals to secant square bracket x cubed plus 3 x squared. Now, I'm going to substitute everything into the product rule formula, which is dy dx over uv prime plus vu prime. Now, I'm going to find the v prime. For tangent x, I will apply the chain rule, and the derivative of tangent x is secant square x. Therefore, v prime will equals to secant square bracket x cubed times 3x squared. Because we're also going to differentiate the value in the bracket, which is x cubed, and it will turns into 3x squared. Now, I'm going to substitute everything into the product rule formula, which is dy dx equals to uv prime plus vu prime. And it will turns into bracket, and it will turns into dy dx equals to bracket ln bracket 3x plus 2 close bracket secant square bracket x cubed bracket 3x squared plus bracket tangent bracket x cubed bracket 3 over 3x plus 2. Hence, the final answer is dy dx equals to ln bracket 3x plus 2, 3x square second square bracket x cube plus 3 tangent x cube close bracket over 3x plus 2. In conclusion, this question involves both the product rule and the chain rule formula.
Next, I'll be explaining the solution for question 3F. Our goal is to find dy over dx for the equation ln 2xy minus cos x plus y equal to 6x minus 3 using implicit differentiation. Let's start by differentiating each term with respect to x. For the first term, ln 2xy, we need to apply the chain rule. Differentiating the outside gives us 1 over 2xy. Then for the inside function 2xy, we apply the product rule, which gives us 2 into xy prime plus y. After cancelling out the 2, we are left with xy prime plus y over xy. Next, for minus cos x plus y, using the chain rule give us plus sine x plus y times 1 plus y prime. And on the right side, differentiating 6x minus 3 simply gives us 6. Now, let's expand and simplify this equation. First, we split the fraction into two parts, y prime over y plus 1 over x. At the same time, we expand the sine term into the bracket, which gives us sine x plus y plus y prime sine x plus y. From here, our goal is to isolate y prime. So let's group all terms with y prime on the left side and move the rest to the right side. Now, we can factor out y prime, leaving us with y prime times open bracket 1 over y plus sine x plus y and close the bracket. Finally, to get dy over dx completely by itself, we divide the right side by the expression inside the bracket, and there the final answer is dy over dx equal to 6 minus 1 over x minus sine x plus y over 1 over y plus sine x plus y.
For question number 4, fx is equals to square root 2x cubed minus 15. So based on the questions, we already know that x is equals to 2.01. The closest value to 2.01 is 2, so x0 is equals to 2. To find the delta x, we need to subtract x with x0. So 2.01 minus 2 equals to 0.01. Then we need to find the derivative of fx. The answer is 1 over 2 times 2x cubed minus 15 to the power of negative 1 over 2 times 6x squared. So we can simplify it. So we got 3x squared over square root 2x cubed minus 15. Then we substitute x0 value into fx and f prime x. So for fx0, we got 1 and f prime x0, we got 12. Then we substitute the value into approximation formula, which is fx equals to fx0 plus f prime x0 times delta x. So 1 plus 12 times 0.01. Since the question was in 4 decimal places, the answer is 1.1200.
In conclusion, the technique of differentiation in calculus are essential for solving real-life problems that include engineering, science, and economics, such as finding the slope of tangent and find rate of change. Techniques such as quotient rule, product rule, and chain rule help simplify complex problems in accurate and efficient way. By mastering this method, the student can develop problem-solving skills which play a vital role in mathematics field and various professional fields. So by that, I'm going to end